Hi everyone, welcome to questions on Boltzmann distribution. So this first question, explain how increasing the temperature increases the rate of reaction. That is what our question is asking us, so make sure we highlight or underline key bits of information. And then it also asks us to include a labelled sketch of the Boltzmann distribution on the grid below. Now these questions, people tend to like Boltzmann distribution questions, tend to get quite a fair few marks for them. So for our sketch, now we need to make sure we have two curves. So to start off with, make sure you draw your Boltzmann distribution curve as you normally would. Okay, so that in this example here with these answers, that would be T1. So the normal temperature, whatever temperature would be, if you're drawing a Boltzmann distribution curve, that's one you should have there. Now they haven't, in this particular mark scheme here, they haven't continued it all the way down to the x-axis, but that line there should go all the way down to the where the x and y axis meet at the very bottom there, and then continuing on as well. Now, because we're talking about increasing the temperature, now we should know that we have to look at that or answer a question of that nature. We then need to draw a second curve on that Boltzmann distribution where we sort of shift the peak a bit more towards the right hand side, and as we see that there with T2. Now, a few things for this. Make sure that you've got your axes labelled up. We need number of molecules on the y, energy on the x. Make sure your two curves don't touch the x-axis. They're asymptotes, so if you know your maths, then they are lines that will not touch the x-axis no matter how far you take it on. So there we are, so we get labelled molecules and energy on their axes. Starting again, pretty much at the origin, do not touch at the highest energy, and making sure you've got both of those there. So you've got your T1 and you've got your T2. Obviously, hopefully, we can show that there are more molecules with energy greater than or equal to the activation energy, and so we should be alright if you have all those there. So as long as you show all those things there, 4 marks, then we should be okay with those. And again, like I say, people tend to like Boltzmann distribution questions, but with the temperature, there's a few more things you're add in there as well. So the second line showing that activation energy shifting down towards the left-hand side, showing we've got more molecules with that energy greater than. Now you can write that down, or you can show that on your curve. Either way, as long as you mention that or write it on your curve, then you get that mark for that. Okay, and then to finish off with, we've got describe and explain the effect of decreasing the pressure on rate of reaction. So again, just make sure we're not messing anything up there. Decreasing the pressure on the rate of reaction. So with this, we're decreasing the pressure, therefore we're going to decrease our rate of reaction, first and foremost. But also along with that, we need to then sort of give a reason as to why that's going on. So we need to then say that we have a decrease in concentration, or we have the number of molecules, particles stays the same, but the volume's increasing, or something along those lines. That has to be coupled in with that first point, so both of those will get you a first mark, and then we can then say we'll have less frequent collisions, or less collisions will be occurring. Okay, so those 2 parts there, so sort of 3 parts really to get the 2 marks, but that answers it in its entirety there. Okay, so that will do for today with questions on Boltzmann distribution. See you next time.